Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so check out Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. Go to pythonpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And to keep track of how your team is progressing on building new features and squashing bugs, you need a project management system designed by software engineers for software engineers. Clubhouse lets you craft a workflow that fits your style, including per-team tasks, cross-project epics, a large suite of pre-built integrations, and a simple API for crafting your own. Podcast.init listeners get 2 months free on any plan by going to pythonpodcast.com/clubhouse today and signing up for a free trial. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the newsletter, and read the show notes. And keep the conversation going at pythonpodcast.com/chat. Your host as usual is Tobias Macey, and today I'm interviewing Rami Al-Rfou about Polyglot, a natural language pipeline with support for an impressive amount of languages. So Rami, could you start by introducing yourself?
Hi, this is Rami. I work currently at Google in language understanding, and Polyglot was my PhD project before joining Google. Before that, I grew up in Jordan and finished computer engineering from there. Then worked in Turkish university teaching computer science. After that, I get a scholarship to do my PhD in machine learning and natural language processing from Stony Brook University, State University of New York. And during my PhD, I was interested in understanding language. And I still remember till today when I joined my lab and was talking to my advisor, he was pointing me out to some tools they developed for English for sentiment analysis. And he was asking me to do the same task for Spanish. And I realized, how much complex their system used to be and how much it could be. It used to be several pieces and modules that you have to hook up together and work on them. And then my advisor switched to ask me, can you do it in your native language, which is Arabic? After a semester of working on Arabic for sentiment analysis, I failed miserably, and I realized that if I want to solve it for Arabic, I should solve it for all languages. And I better think about a different strategy of how to tackle large number of languages instead of one at each time. Because once I'm done with the first one, I will be asked for the second one and the third one. And definitely at some point, my skills in this language will be zero to do anything useful. So we should let the machine learn, not ourselves.
And do you remember how you first got introduced to Python?
So Python is not something my university used to teach. There's a lot of emphasis as electrical engineering, computer engineering on assembly and C. But the computer science used to be the .NET languages like C# and VB, Visual Basic, and so on. I was interested in Python because I found the syntax to be really easy to remember and write, and I'm a kind of a lazy programmer where most of my projects not necessarily the kind of jobs I have to do. So it was quite a productive environment to work on. So every time I come up with an idea or something, Python would be my first language. So I learned it by myself. I used to be hanging out in the IRC channel of Python, and every time I get bugged, these are the days before Stack Overflow. So whenever there is a problem, I would be just nagging the people there. They will be annoyed, but they will answer me eventually, and slow by slow. There was no point where I had to master the language, but over time, because it's my default language and my comfort zone, I start mastering it more and more over time.
And so you were mentioning that in the process of your research, you were tasked with trying to add support for natural language processing for Spanish and Arabic, and that led you to wanting to build a solution that would work for all languages. So I'm wondering if you can describe a bit about the Polyglot project itself and some of your experience of getting that started and how it works.
So the Polyglot project, the aim of it is to elevate the status of NLP projects and packages, in the sense that when people develop something called NLP, natural language processing, they should not be doing NAP, which is natural English processing. They should be with the mindset that their systems should be as applicable as possible to all languages. And that's really a hard task. That's a research task. So, the current status that many packages do not support many languages comes from it's not an easy thing to do. But I believe compromises has to be done to actually put coverage of languages as a first priority over everything else. So Polyglot initiated from the fact there was a lot of progress in deep learning around the time I started the project, where people historically used to calculate features from languages manually. So they would look at case and look at character engrams, and they would look at annotations like verb, subject, and so on. And these annotations and features are not consistent across languages, and need a lot of domain knowledge in each language. So a lot of progress happened in deep learning, in the sense we can learn feature representation of words without actually knowing the language, and that comes just from the corpus statistics of the language. So when I realized, I can learn features of every word in every language automatically. We call it word embeddings, and word embedding means a vector that represents a language, a word. And imagine a simple case where you have a 3D room, and I'm telling you, put the words in the space according to their meaning. So in one corner you will find like places, and another corner you find names, but another corner you will find verbs, and the verbs that describe walking are closer to each other than the verbs describe drinking. And if I tell you do it as a human, you will really spend a lot of time not sure how to put words and how much the space will be enough, given it's only 3 dimensions. What our machine learning is trying to do is literally put these words in points in the space, but the dimension usually is way higher. We are talking about between 50 dimensions to 500 dimensions. And when we look at the nearest neighbors for every word in that space, we find they correspond really well to our understanding of the meaning of these words. So you will find Obama closer to Bush, and you will find Apple capitalized closer to Google, but Apple lowercase closer to orange, dog close to cat, coffee close to tea, and so on. So given this technology, I decided, okay, why not we develop these word vectors for all languages? One challenge to do that is, where is the corpus that could cover 100 languages? And that by itself is a really tricky business. So every time there is a problem where you cannot get resources for multiple languages, usually my first answer was Wikipedia. First, the corpus is available, to download easily. But not only that, there is a significant volume of text in each language in the ones supported Polyglot. So the first step was to learn word representations, which we call word embeddings, for each language. And that meant take the state-of-art methods at the time and run them on the corpus of Wikipedia for each language. And that end up with a dictionary where you have, for every word in that language, a vector representing that word.
So it sounds like Wikipedia is essentially your digital Rosetta Stone for being able to establish some sort of commonality between the languages and the features that you're trying to optimize for, in being able to generate these word vectors to be able to establish an appropriate vector space for doing analysis and entity extraction from any sort of arbitrary corpus of text within a given language.
Yes, I mean, we will, if we go after every task that Polyglot achieves, a lot of them, not only that the feature will extract them from Wikipedia, but we also utilize the structure of Wikipedia to actually help us with the annotations. So I'm not sure if you want me to delve deep into these, or we go into them later.
And so for Polyglot itself, what are some of the main use cases that it enables, which would be either impractical or impossible with something such as the NLTK or Spacey libraries or GenSim that don't have as broad of a language support?
I mean, basically, the distinguishing thing in Polyglot is that the number of languages we support. I mean, that came at cost in terms of equality. So if only your concern is English, the other libraries offer better quality because of the technology they used depends heavily on resources only available for English. So while developing Polyglot, we had to rely on heuristics and a lot of tricks and hacks to get annotations and pseudo annotations to develop tools for other languages, but that came at a cost of quality. So if you are a person who wants to work on a language that these libraries do not support, Polyglot will be your first start. If you are interested in semantic meaning of corpus in other languages, the word embeddings Polyglot offer is a good start. And yeah.
And you mentioned that there's a significant amount of effort involved in being able to add support for any given language to a natural language tool such as Spacey or NLTK. So I'm wondering if you can dig a bit more into the types of difficulties that you would face when adding support for a new language as a sort of incremental step versus the approach that you're taking with Polyglot for being able to do it in a deep learning approach.
So let me explain. Let's suppose we want to develop an application called named entity recognition, and the goal here is to extract from document entities that were mentioned, like locations, persons, organizations. In a typical setup that NLTK will take, or Spacey, or Stanford NLP, first you have to develop annotations. So you would go after a corpus, and the corpus will be not annotated. So you will have humans annotating where the entities show up, and that involves like tens of thousands of entities has to appear. So you are going over like hundreds of thousands of sentences. Second thing, you will go and develop features for that task, and usually for named entity recognition, people would look at character of engrams and casing, which is not consistent across languages, but you still will rely on them. Then, given the features you extracted and the supervised data you have, you will train a machine learning model to annotate, to learn the named entity recognition. In the polyglot world, the approach was quite different. We learned features for these languages using Wikipedia. So if you have a new Wikipedia for a new language, you just have to run a tool like Word2Vec, and that will embed your words into vectors. For annotations, given we didn't have the resources, and these resources are not going to scale for all languages, we relied on the link structure of Wikipedia. So what that means, in the first couple of paragraphs in Wikipedia, if an entity get mentioned, usually it get annotated and linked to its own page. So we know the set of pages in Wikipedia that correspond to entities. So if a mention points to a page that page already is an entity, we will call that mention, that phrase, an entity phrase. So automatically that will allow us to have a huge amount of supervised labeled corpus. Now that doesn't come with the highest quality we would expect, because Wikipedia forces its writers to only annotate the first mention, but not the later mentions in the document. So in our paper working on that problem, we designed a couple of heuristics to accommodate for that style, Wikipedia style. So first, we have higher confidence in the positive labels than the negative labels. So if something is mentioned to be an entity, we quite confident. If something was not an entity, we are less confident because it could have been just not annotated according to the standard. And the second thing, we usually focus on the first couple of paragraphs in the corpus, but not the later ones. So that end up with a huge amount of annotations. Given the features we can automatically extracted for the text and the annotations, we train a deep learning model, a feed-forward network, to actually predict these annotations.
And for somebody who's interested in adding additional corpus for a given language to Polyglot to more easily fit the particular problem space or set of topics that they're going to be working with within their project, what's involved in being able to either update the model or retrain Polyglot to be able to handle some of these additional entities, and how much upfront work is necessary as far as labeling or feature extraction for Polyglot to be able to take advantage of the corpus that they're introducing?
That's a great question. So basically, the work on Polyglot started in 2013, and since then we are like more than 5 years down the line. The technology evolves so significantly that there is new methods to develop word embeddings, and there are that definitely outperform the way we have been doing it in Polyglot. So consistently, the people ask me on the project, "Oh, I need embedding for a new language, or I trained on something not Wikipedia." My first go-to is Word2Vec, which is available through Gensym to develop the word embeddings. And basically, why I'm advising that, because the methods has been constantly improving, and you guys are aware of the machine learning, deep learning revolution happening in the last 6 to 7 years. So the technology is consistently changing, even up to last 2 weeks, where a team here at Google was also publishing embeddings in a new method over so many languages called BERT. So things keep moving fast. So if you want to add a new language, I would say I will focus the first thing into developing a word embeddings for that language. So two things that I would focus on: first, finding the corpus the closest to the domain you care about. So if your domain looks like a news, it would be great if you collect a corpus of news. If your domain looks like a Wikipedia, then you are good to go. So first thing, collect the corpus that looks as close as possible to the domain you care about. Second thing, use one of the state-of-art tools to develop word embeddings using Word2Vec or BERT or fast text. Gensym encompasses several of them, but not all of them. And the other tool is also available in Python. Once you have your word embeddings or phrase embeddings, now you come with the annotations. So that is a common question I get in Polyglot. Oh, Polyglot annotates organization, persons, and locations, but I need more. And the problem with a lot of NLP application is just the annotations are hard to get. So while in Polyglot we relied on the Wikipedia taxonomy, there is no reason not to do it with larger taxonomy. So when we went to Wikipedia and looked at the annotations of each page, we only concentrated on grouped organizations, persons, and locations. So what you really need to do is to re-annotate the text according to a wider definition of pages. So any mention that points to pages that more than these three, you will also introduce it as a new label. So basically, what is really necessary to happen is basically re-extracting the corpus from Wikipedia. In our page, we already released the corpus we extracted, but that doesn't include the taxonomy. And unfortunately, in the last 3 years, we relied on Freebase to give us annotations over Wikipedia pages to classify them, and the Freebase is not available anymore. So I'm not sure if Wikipedia nowadays have their own taxonomy on top of their pages, and how things go. It used to be also really hard to extract clean text from Wikipedia because of the wiki markup, but over the last 3 years also they developed tools to make it easier and easier to do that. So in one side, Wikipedia became easier to get clean text, but on another side, we lost Freebase as a source of taxonomy over Wikipedia.
And are there any particular families of languages that are more challenging to support than others, whether because of the ways that their text is encoded, or the grammatical structures, or the way that they refer to entities within the language, or the semantics of how the language is constructed?
Absolutely. So there are different sets of complexity come from different reasons. So one of the complexity is tokenization, and tokenization usually in East Asian languages is, if you look at the polyglot code, we end up using a different tokenizer than the one we use for the rest. And that comes from the fact that Chinese script and Japanese and so on, especially Japanese, because of the mixes of three different writing systems, end up really hard for tokenizers to get right. So that's one issue. Another issue comes from other languages like Turkish, Arabic, and Finnish, where they have really sophisticated morphology, and their morphology end up like making creating so many words that are just compound words. So what do I mean by that? Usually in Polyglot, we concentrate on the top 50,000, 100,000 words. Okay. How do we select the top 100,000 words? The most frequent ones. And usually in English, the most frequent 100,000 words cover almost 98% of the text. When it comes to a language like Arabic or Turkish or Finnish, with the most frequent 100,000 words, you barely cover 90% of the corpus. And that leads to degradation in the quality of your system, because every time you encounter a word that's not in your dictionary, it's out of vocabulary, and out of vocabulary get represented with one single vector, and that makes the classifier you don't give the classifier enough informative data to actually make a good decision. So languages that have complex morphology end up with a lot of sparsity, and languages that tokenization is not as easy. Now, both issues could actually be solved using a different approach to building NLP applications. That different approach is to build application from byte level representation. So instead of relying on words as the unit of the sequence, text sequence, why not rely on characters or bytes? So if Rami gonna rebuild Polyglot in 2018, what he's gonna do is build representations of language from the characters and up, and that will allow you to represent complex languages and morphology like Arabic and Turkish. Also, you don't need a tokenizer or normalizer. And that's a great blessing, because normalizer and tokenizer do not work consistently and robustly across languages. And every library has really different scheme of tokenization depending on the language.
In terms of the types of operations that Polyglot supports, I know that it is able to do, as you mentioned, tokenization and entity recognition, and being able to extract the different morphemes within the text. And when I was looking at the documentation, it looked like there were varying levels of support across languages for some of those different operations. So I'm wondering if you can talk a bit about the challenges of supporting some of those different processes that you might want to run against the given languages, and how the nature of the language itself may complicate being able to support it as thoroughly as some of the other languages.
So basically, we have different varying support for every prediction. So for part of speech tagging, we have support for 40 languages, but for name recognition, we also have 40, but for morpheme analysis, we have more. Word embeddings, we have for all of them. Tokenization, we have for all of them. Basically, and by all of them, I mean like the 100 languages we support. The varying support comes from the varying level of annotations we can acquire. So as I mentioned earlier, for named entity recognition, we relied on Wikipedia to extract mentions. But for part of speech tagging, we relied on the NLP community to get annotated corpora. So, and these corpora only cover 40 languages. They don't cover more, and they are expensive to collect. For morpheme, it's unsupervised task. So in the sense, it doesn't need morpheme analysis. So it doesn't need collecting a corpora. So it was easy to push for all languages. So really the bottleneck for developing in new languages, it comes from, do you have annotations for the task you need? And again, annotations are costly in the sense either you buy them by making a mechanical Turk task where you ask people to annotate the corpus for you, or you do it manually, or as I did in my PhD, just do a lot of clever tricks to do data mining on corpora that almost get you there without actually human intervention.
And so I'm wondering if you can talk a bit more about the way that Polyglot itself is implemented in terms of the software design and architecture, and some of the major libraries or services that you leverage to be able to put it together.
Yes. I mean, the design of Polyglot was emphasizing on simplicity. So just to encompass a lot of tasks and a lot of languages, basically, the library actually consists of, kind of in my mind, in two parts: the software and the models. And the models used to be, takes a lot of storage, so it was hard really to push binary blobs into GitHub to store them. So we decided to store them on a server, and we forked the NLTK downloader package to actually manage our own resources. So similar to the experience you'll find in NLTK, you can browse the Polyglot index of resources and download according to language or according to task. And this usually used to be hosted either on Google Cloud or on my university server. So that's one part. For the software part, Polyglot has dependencies for tokenization and language identification on several libraries. So language tokenization comes from the ICU lib. For language identification, it comes from Google library that used to be integrated within Chrome. Then Google open sourced it, and they wrote a Python wrapper for the C library they had, and then Polyglot depend on that library. For the morpheme analysis, I used the work of a research group and used their Python library actually to train a morpheme analyzer for each language, giving the corpora I have. So then I uploaded the models. So basically, Polyglot is a collection of other people's effort plus the effort I did in my PhD. In terms of software design, I would say basically the greatest value of Polyglot is the pedagogical value, in the sense I see the largest usage is through students who are taking the first time machine learning and NLP course. I get a lot of requests and questions from them because they find it kind of transparent. It's quite easy to get through the code and just figure out what is going on and modifying it according to your class project.
And is there any capacity for being able to integrate Polyglot with some of the other tools in the ecosystem, such as Spacey or GenSim, to leverage the additional algorithms or capabilities of those libraries once you've done the either part of speech tagging or tokenization using Polyglot within the languages that are supported?
I mean, some libraries approached us to use the embedding resources we have, and we were welcoming in general. I personally don't have the capacity, given my life and work schedule, to do more significant development other than maintenance.
And for somebody who's building an application or a project and using Polyglot, is there any particular domain knowledge in terms of natural language understanding or natural language processing that's required to be able to use Polyglot effectively within that application? Or is it fairly easy to get started with a surface understanding of how the API operates and be able to leverage the capabilities of Polyglot to gain some capacity for being able to process free-form text?
So the API, I think, will be straightforward to use, and I don't think you really need to know much about how it's working, because from language identification to tokenization to morpheme analysis and for semantic similarity of words, all of these, you could just use them as the API offer them. One thing you need to be aware of is that the way these models are trained, so the way these models, your expectations of what the models will do, should be highly influenced by understanding on what they were trained and how they were trained and under which conditions. So a machine learning model will not do something it was not trained to do. So again, for named interrogation, for example, we trained it for 3 entities, and people ask for more entities. And for more entities, you need to retrain the model. The model is not going to achieve. It was trained on labels that was extracted automatically. So the quality of the classification will not match the state of art in English offered by the Stanford package, for example. Every task was trained, depending using different research mechanism, And if the quality of what is the annotation is producing or the results are a little bit surprising, I advise people to just skim the paper how we actually implement these things, because given the way we implement it, it's fair for the model to behave that way, but it may not match what you expect the model to do, if that makes sense. So again, the goal of the Polyglot is to push the community toward large scale coverage of languages, and we had to make compromises along the way, and some of them came on not collecting human annotated data sets for each task for each language, because we thought that not feasible.
And are there any particularly interesting or unexpected or unique uses of Polyglot that you have seen?
I'm actually surprised by the attention I get. My expectation that was a project to put all my effort in my PhD and package it in a presentable way, but over the time I was surprised by the attention it got and the number of people use it, and especially the number of startups. Again, there is a lot of demand for machine learning and AI to be integrated in so many applications. So I guess that pushes toward that. I'm always delighted by the number of researchers and students who approach me from all over around the world, and the nice words I receive from people like I will never meet and remote areas in the world just make me quite happy. So I still remember people approaching me from Indonesia, Bangladesh, Ethiopia, Angola, and in all honesty, I felt like that was quite the reward. Most of what I see, other than small teams trying to get coverage in new markets, so they like Polyglot because it gives them unified interface for tokenization, language identification across languages, and an easy API. I found it a lot of many schools, when they teach NLP for undergrads, they tell them about the package, or the students find it easy to integrate into their projects.
And in the process of researching and creating and maintaining Polyglot, I'm wondering what you have found to be some of the most interesting or unexpected lessons learned and some of the biggest challenges that you faced along the way.
So there are things I didn't anticipate when I was writing the code. As one thing is the huge demand for Windows support. I historically started using Linux since like 2006 when I was an undergrad. So in my mind, when I was developing the package, there are things like felt to me like quite defaults, like path separators and so on. And I stated like clearly in the documentation, this is only being supported in Linux. But if you look at what people request usually and the questions all about, pretty much more than 2/3 of them are like, we need to run this on Windows. And I don't have the machine that has Windows support, and I don't even have the experience to develop Python on Windows. So that's kind of weakness on my side, but I'm not sure if the community as a whole have tools that makes it. I know that Python has tools to convert Python 2 to Python 3, but are there tools for Python that says, well, this is a tool that will package your software such that we tested that will actually not break on any platform. At least, not semantically it's not going to break, but at least, your path, the way you constructed path and the way you are going to do this and that, all will align. You called all the right functions and you didn't use lower level libraries that will break portability. So that's something I didn't anticipate. And it was great to have a website for documentation, read the docs. But I think its integration with GitHub is not optimal, in the sense many people don't find the documentation. They find the GitHub repository first. So many of their concern already being answered in the documentation, and maybe something I should look into.
And now that you're working full-time with natural language understanding, I'm wondering how much time you have to be able to dedicate to any further development or feature enhancements to Polyglot, and what you have planned for the project in the future.
That's a great question. So I'm quite honestly busy with the research I do. I still do research in natural language processing, and my focus, while not necessarily on multilingual anymore, but I am quite aware of the challenges in multilingual work. So I work hard in developing NLP technology that doesn't need that avoids all the bottlenecks that come in multilingual processing. So basically, our recent effort into developing byte language models and byte level processing is all for the purpose of making it easy to deploy different languages and different genre of languages without the need for normalization or tokenization, which is a big hurdle in so many applications. So if we can just read the bytes and do processing without even observing the words, that would simplify a lot of things. So I would say I have only time for maintenance of the package, but when it comes to feature development and improvement, I would think it's maybe time for Polyglot 3 or 2, where we actually do all languages from byte level, develop embeddings from the byte level, not from the word level, and do more semantic tasks. In the sense, develop embeddings, vector embeddings for words, phrases, but without the tokenization and normalization. And I think that would be actually more robust for more applications and more people, and train beyond just Wikipedia. So if I have the time and maybe the volunteers, I would be happy to guide them through the process of building on the same basis, keeping the same kind of package, but adding more embeddings that are take advantage of the recent developments in natural language processing and deep learning, and basically to my biggest goal to simplify support of massive number of languages is just to do the processing on the byte level. So you avoid a lot of the pre-processing and you become more robust to typos and misspellings and different genres. Like, imagine a tokenizer for English. How would it work on Twitter? Twitter is English, but not real English. So I think, what is the definition of a language? What is the definition of a dialect? What is the definition of a genre? These are all blurry lines. I mean, just take Brazilian Portuguese, for example. You have Brazilian Portuguese and you have Portuguese. So, and you have Angolan one, and the vocabulary is a little bit different. The punctuation may not be consistent. So there's a lot of changes across countries. And instead of enumerating them in software, I think the wave is the future is just to let the machine learn all of these. So I would say my biggest dream for Polyglot is to publish a new Polyglot that is do byte level of processing and make it like the foundation for everything we did before.
And are there any particular areas of NLP research that are currently in sort of the early or experimental phases, or anything in particular within natural language understanding that you're excited for?
Yes, absolutely. So recently we just got a paper accepted in AAAI on byte level language modeling. There is other effort in Google called BERT, which is also a language model, bidirectional language model that supports so many languages. I think my colleagues here already published this embedding and vector representation for more than 100 languages also, without classifiers on top of them, just the embedding of a phrase given for each of these languages. So I would think that given the amount of new hardware coming and the acceleration of hardware we are seeing nowadays, the NLP research will be exciting to move forward to less pre-processing, less interference, and let the machine do more of the work of processing the text. So there used to be an area of where people develop word embeddings and word vectors, and I think the future will be no pre-processing, no tokenization, no word observation, and just directly from a sequence of characters to a representation in the space. And I think that will be quite exciting. Recently, people have achieved superhuman results in question answering, so I'm looking forward to the new challenges that will be proposed that will push our research forward.
And are there any other aspects of natural language processing and multilingual support and the Polyglot project that we didn't discuss yet, which you think we should cover before we close out the show?
Hopefully I give people the right expectations, because a lot of what I receive is people expecting things to work in 2018 while they were developed in 2013 the same way. And I feel like I wish I had more time to develop these things. But given that it's mainstream nowadays to develop embeddings for all languages, given, for example, my colleagues publishing like 100 languages embedding, I think the concerns I had in 2013 where the community is not doing NLP for all languages is over time becoming not the issue, because just deep learning is advancing fundamentally such that actually easier to develop for new languages. The one thing that will make it absolutely easy is just the availability of corpora, and second thing, the availability of a lot of computation that allows us to process on character level. And I think that maybe one thing we can call the community is like, a lot of people, I find a lot of people approaching me. I have Ukrainian corpus that has different annotations and so on. I wish there is an easy way like GitHub where people publish their annotated datasets. So because like there will be another student like Rami who's sitting like, you know what, here is the GitHub of datasets and these are annotated, and I'm going to train my classifier on all of them and put them part of my package. And now we have a package that does 100 tasks in in 100 language. But it's just a problem sometimes, like where do you find there is no consistent place? I think that would be a nice thing to have. I know Google published a dataset search engine, but maybe that's not what we need. Maybe we need more of a community-based GitHub, but for datasets.
A couple of places that you might look at on that front there's a company called Quilt that has an open source platform for data collaboration, and there's also, it might not be quite the right fit, but there's also the data.world company for hosting public data sets and being able to collaborate on those. And so I'll add links to those in the show notes, as well as links to interviews I did with some of the people behind those projects on my data engineering podcast. So for anybody who's curious to learn more about those, I'll add those links to the show notes. And so for anybody who wants to get in touch with you and follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose the Duolingo platform, which is a great and free site for being able to learn new languages. So I've been using it to practice some German, and it's an enjoyable interface. It makes it very fun and easy to pick up a few minutes a day. So definitely worth taking a look at if you're interested in learning any new languages. And so with that, I'll pass it to you, Rami. Do you have any picks?
Nowadays, I'm reading a book called The Prophet and the Wizard, and it's about the two campaigns of how people look at the future of Earth. So the wizards are the scientists who says we can increase the capacity of Earth with our innovation, and the prophet says, well, disasters are coming because we are exceeding what the Earth can actually sustain, and therefore we need to consume less and grow less. So it's a fantastic read, and without heated discussion or politics, just giving you the stories of people behind these and their thoughts on how the future is going to go for us.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you're doing with Polyglot. It's definitely a very interesting project, and it's always great seeing people expand the availability of the being able to work with multiple languages. It's definitely important as more and more people come online and get involved in the modern era. So I appreciate your work on that, and I hope you enjoy the rest of your day.
Thank you. Thank you so much.